There is a photograph taken on December 24th, 1968, that changed everything. Astronaut Bill Anders, orbiting the moon aboard Apollo 8, looked out his window and saw something no human being had ever seen before. The Earth, small and impossibly blue, rising above a barren lunar horizon. He grabbed a camera and took the shot. In that single image, humanity saw itself for the first time. For the 4 years that followed, the moon was ours. 12 astronauts walked its surface, bounced in its low gravity, drove lunar rovers across its ancient plains, and brought home 842 pounds of rock that would rewrite our understanding of the solar system. The Apollo program was the single greatest achievement in the history of exploration. And then, in December of 1972, Gene Cernan climbed back into the lunar module, and we left. We just left. The moon watched from a distance. Robotic probes visited. Telescopes observed. But no human foot disturbed its dust. The reasons were always the same. Budget cuts, shifting political priorities, the Cold War ended, and with it, the urgency that had driven Apollo. The moon became a memory. But here's what we didn't know in 1972, or rather, what we suspected but couldn't confirm. The moon is not empty. It is not simply a dead rock hanging in the sky. Permanently shadowed craters near the lunar South Pole, regions that haven't seen sunlight in billions of years, are filled with water ice, billions of tons of it. And where there is water, there is possibility. Water can be split into hydrogen and oxygen, rocket fuel. The moon could become a refueling station, a waypoint, a launching pad for the entire solar system. This changes everything about why we go back. That is the world this story begins in, a civilization with the knowledge to return, the technology to do it better than before, and, for the first time in half a century, the will to actually try. The Artemis program is NASA's answer to that challenge. Named after the twin sister of Apollo in Greek mythology, and, crucially, a program that would put the first woman and first person of color on the lunar surface, Artemis is not a repeat of the past. It is something more ambitious, more complicated, and, if we're being honest, more troubled. The centerpiece of the program is the Space Launch System, or SLS. It is the most powerful rocket ever built, capable of generating 8.8 million pounds of thrust, more than the Saturn V that carried Apollo astronauts to the moon. Sitting atop it is the Orion capsule, a spacecraft designed to carry crew on missions lasting up to 21 days. Together, they represent decades of engineering and tens of billions of dollars. The development was long, painfully long. There were delays, cost overruns, technical setbacks, and moments when the entire program seemed to be teetering. Critics called SLS the Senate Launch System, a rocket kept alive by congressional politics rather than engineering logic. The debate was fierce. And then, on November 16, 2022, the world watched as SLS lifted off from Kennedy Space Center for the first time. The ground shook. Windows cracked miles away. And Artemis 1, an uncrewed test flight, arced into the black sky, sending the Orion capsule on a 25-day journey around the moon and back. It worked. Beautifully. But the rocket is only part of the story. The real conflict of Artemis, the dramatic tension at the heart of this mission, is the question of how humanity builds a permanent presence beyond Earth. Because this time, NASA isn't just going to plant a flag and leave. The plan is to stay. That requires infrastructure that has never existed before. The Lunar Gateway is a planned space station that would orbit the moon, serving as a staging point for surface missions. Commercial landers, including a spacecraft built by SpaceX, derived from its Starship rocket, would ferry astronauts from the Gateway down to the surface and back. New spacesuits, new rovers, new communication systems. It is a cathedral of technology being built simultaneously across dozens of companies and international partners. And those international partners matter. The Artemis Accords, signed by more than 30 nations, establish a framework for peaceful exploration and resource use on the moon. This is no longer an American program. It is a coalition of humanity reaching for the same goal. Canada, Japan, Europe, Australia, all sending their own astronauts, contributing their own modules and instruments. The geopolitical dimension adds another layer of tension. China and Russia are developing their own lunar program, racing toward the same South Pole resources. The moon, quiet for 50 years, has become contested territory once more. Then, there are the things that go wrong. Because in spaceflight, something always goes wrong. Technical issues with the Artemis II crewed flight test pushed timelines. Hydrogen leaks during ground testing. Weather scrubs. The arc of this program is not a smooth ascent. It is a struggle, a climb, 2 steps forward, and 1 step back. That is the reality of doing something this hard. Every delay is a reminder of what is at stake. Every success is hard-won. Humanity knows what it wants to do, has committed resources and talent on a historic scale, and must now fight through every technical, political, and logistical obstacle standing between intention and reality. The moon is waiting. The question is whether we are ready. Here is the thing about Artemis that gets lost in the technical details and the schedule debates. It is not really about the moon. Yes, the landings are breathtaking. The science is irreplaceable. The images of astronauts descending into the permanent shadow of a lunar crater and scooping up ice that fell there before dinosaurs walked the Earth. That will be one of the most extraordinary moments in human history. But the moon is not the destination. It is the training ground. Everything NASA learns from Artemis, how to keep humans alive for long periods in deep space, how to extract and use resources found off Earth, how to operate spacecraft far from home with limited communication windows. All of it feeds directly into the next mission. Mars. The moon is where humanity learns to live off-planet. It is a rehearsal, conducted 240,000 miles from Earth, rather than 140 million, so that if something goes wrong, we have a chance of coming home. Think about what that means. For the first time in history, our species is not just exploring, it is preparing to become multiplanetary. The Artemis program, if it succeeds, plants the seed of something that will outlast every one of us. A permanent outpost on the moon. Eventually, boots on Mars. The arc bends toward the stars. And there is one more thing worth saying. When that first woman steps onto the lunar surface, when the first person of color looks back at the Earth from 250,000 miles away, the image will do something that no policy paper or diversity initiative ever could. It will change who children think explorers look like. It will rewrite, in the most visceral and undeniable way possible, the story of who gets to be part of humanity's greatest adventure. That matters. It matters enormously. Artemis is named for a goddess of the hunt and the moon. But in Greek mythology, Artemis was also a guardian, a protector, someone who watched over boundaries and wild places, and the things that mattered most. Perhaps that is the right metaphor. Humanity is not just going to the moon to conquer it. We are going to learn how to be its guardians, and in doing so, to become the kind of species that deserves to inherit the stars.